Hey, so I was going on YouTube recently and I came across this video.
For that, I again need to touch server-side code, projectile add some constraints for how far can I build projectiles.
Yeah, I just couldn't resist. Sorry about that. Multiplayer, let's make one. But first, we need a game. The one I had in mind for this project is a game called Killer Bean. This is a game I played a lot growing up, and although it had all the attributes for multiplayer like gunfights, multiple enemies, explorable maps, and an incredibly large fan base, the developers just never made one for some reason. That's where this guy comes in. That's me, by the way. I'm going to make from scratch my own version of the game and make it multiplayer. And when I say from scratch, I mean I'm not allowed to use a game engine or external libraries. Everything from the game mechanics, physics, down to the server will be written purely in TypeScript, Node.js, and WebSocket. And it all starts with a black canvas. Well, not for long. Let's draw a square. That's it? What do you mean that's it? It's 2 lines of code. Right. Trying to make this 10 minutes. It might not look like much, but this will be, meaning it can't just stand there looking pretty. We need some movement. Luckily, some random dude in the 18th century discovered something called laws of motion, where an object will only move if a force is applied to it. To do that, we introduce something called a velocity, which is just a fancy word for saying how fast you're moving. Our object's position will always be incremented by its velocity. If the velocity is at 0, nothing happens. Change the values and the change of values in velocity is the force acting on the object, which we can then map to keystroke on our keyboard. But this looks pretty unnatural for a platformer. Legend has it the same motion guy got hit by an apple and he discovered something called the law of gravity, which is weird because he could have also figured out that by taking a shot. Gravity is a constant force that increases an object's velocity across the y-axis, aka up and down. But as we have gravity, we also need platforms to land on. If we know the width and height of two rectangles along with their positions in space, we can check if they are touching by comparing their edges. That's if the right edge of one rectangle touches the left of the other, or if the bottom of one touches the top of the other, etc. Scientists call this a collision detection. We can then use this to stop the object's velocity depending on which side touches which. Don't worry, the game isn't going to be all squares and rectangles. I've spent some time preparing some pre-generated sprites we can use. Speaking of use, what we shouldn't do is to make them into separate image files, because even though it's much faster to code because we just read the names, it's not very efficient because our program will have to load each individual file. What we should do is stack them into one image, read their coordinates separately, and crop out the parts we want. This way we only need to ever load one image file, saving it on our memory. The math is a bit more complicated than that, but I already wasted saliva on this topic in my Mario clone video, so if you want more details, just watch that one. After you're done with this one, of course. Although we can move, we shouldn't be able to move past the view of the canvas. Since we are coding everything from scratch, we can't just magically slap in a camera and call it a day. This means we have to improvise. There are many ways to go about this, but the most common one is something I call the draw box method, which, as the name says, you draw a box around the player. You're probably wondering, what's the point? Well, the draw box method follows one rule. Never lift the canvas. Meaning if it touches the left or right of the canvas, we stop moving and instead move everything else to the opposite direction. This works fine, but what about moving up and down? You're probably like, well, Divine, it's the same thing. If it touches the top or bottom, we stop moving and move everything else. And you're right, that's exactly how it works. But we still need to consider gravity. Let's say I had a bunch of objects in the scene, they move sideways or downwards, everything looks normal. But if you go up, watch what happens. There, you see that? This happens because the motion of the object due to gravity doesn't align with the movement of the camera. But don't panic, this is a minor issue. You can just throw a simple hack that temporarily disables the gravity of the object when the camera moves downwards, so we no longer get that very bouncy effect. Do I like the solution? Yes. Is it the most optimal? No. There are cases where this could be an issue, but the chances of them actually happening are like near zero, so we'll just stick to this for now. Alright, enough about cameras, let's shoot people. The way shooting works is by creating each individual bullet and then passing it into the word array to be rendered. But doing it this way is a bit unnecessary. Bullets are temporary items, so we don't need to bother the world with their existence. Instead, we can create a separate array, create the bullets, set the velocity to a fixed speed, push them in the array, and then just draw them individually. We can then track their movement to the bullet class and detect hits using our, you guessed it, collision detection, and then make the objects they hit respond accordingly. Speaking of classes, every item in our world is grouped into them. There's the tile class, which are immovable objects that act as platforms. There's the item class, which are objects that have physics and can be interacted with. And then the player class, you and me. Each class acts as a blueprint for all objects in our world. We are writing everything from scratch, so the best we can do is make the code more manageable. So I don't get the urge to punch my computer when I look at it in the next 7 months. Now what's the point of shooting people when they can't respond by throwing grenades at you?
Grenade!
When you throw an item forward, 2 types of motion happens. The horizontal motion caused by you when you throw it, and the vertical motion caused by gravity pulling it down. By controlling the angle we throw the object along with the initial velocity we give it, we can very easily predict where the object will land. This is called a projectile motion. There are a bunch of other things to figure out in math like the maximum heights, range, time of flight, etc. But we're making a platformer, okay? We don't need all that information. Okay, now that we have a pretty solid game, it's time to tackle multiplayer, which is like, the whole point of this video. Basically, the whole process involves two things: a client and a server. The server acts as a source the clients connect to. For every person that joins, their client gets all the data from the server to create the game world on their computer. This includes all its components and even the other players themselves. In a game like Call of Duty, for example, the other player you're seeing isn't exactly the player themselves. It's a copy of the player. When they move, their client sends the new position as a message to the server. The server receives that message and sends it to the other client to update their copy's position. It might sound like a lot, but this actually happens extremely fast. Modern WebSockets can handle up to thousands of messages in milliseconds. However, the internet is connected by a bunch of cables buried beneath the ocean, so if a client is considerably far from the server, the long distance will cause those milliseconds to eventually pile up, resulting in latency. Something really cool we can do is calculate the latency for the client. Basically, every second, the server gets its current time and sends the data to the client. When the client receives it, they will get their own time and subtract both values. The difference in milliseconds will be the client's latency, or as the gamers call it, throw a ping. Pro tip: you can maximize your server's efficiency by sending only necessary information, while the clients predict the rest. Take for example, let's say a player shoots their gun. There is absolutely no need to send each individual bullet's position to the server. You only need to send one message, which is when they shoot, while the copies of the other clients mimic the same action. By doing this, you are lessening the burden on the server, which in return makes it more efficient. That's it, we're done.